So we are going to do a quick recap of Lesson 2, which is called, the lesson title is Sum or Difference of Cubes. So a cube looks like this. Here's the expression, and I could take any natural number. Natural numbers are what you naturally start counting with when you are a toddler. So 1, 2, 3. So I'd go 1 times 1 times 1 3 times, 2, 2, 2, multiplying it, 3 times 3 times 3. Remember, you're multiplying, not adding. 4 times 4 times 4, and so on. So this is all the way up to 10 cubed. Again, it continues to go. And so we're going to start with some basics. So let's start with this one. X cubed minus 27. Now, what's different about this lesson compared to lesson 1 is we're working with cubes here, not with perfect squares. You could have addition or subtraction. You can have addition or subtraction to make this work. When you don't see a number out front, it happens to be a 1. So is 1 part of this list? It sure is. 1, 1, 1. And x breaks into x to the first, x to the first, x to the first. 27 is here. It's the third number. So this is 3, 3, and 3. Now, with sum or difference of cubes, if I could make this into a stamp, it would always be looking like this. 2 blanks in this first parentheses and 3 in the second, and there's always a plus sign here. Every single time it's looking like this to start with. Every single time. Okay, so what do I put into here? So the symbol you see in the original expression is going to go in between the first 2 terms in the first parenthesis. So the 1 and the x come before the subtraction sign, and then I'm going to cross them out so there's no confusion. The 3 goes behind, so it's going to go behind. What do I do with these leftovers? Well, this is the front. So 1 times 1 is 1. X times x is x squared. It came before, so it's going to go in the front. I'm done with those. And 3 times 3 is 9. Now this middle section, the symbol of it is going to be opposite of the first symbol. So the first symbol is subtraction. So for this expression, it will be addition. And to come up with this term, you're going to multiply these. Do not worry about the sign. We already have it. 1x times 3. 1 times 3 is 3. Attach an x. This problem is done. So I have completely factored. If we FOILed this out, we would end up, after simplifying, with this exact same expression. Here's our next one. 16x cubed plus, give me 1 second here, plus 250. So, again, it does not matter if it is addition or subtraction. I have a cube, so that's just telling me right away, okay, I'm doing sum or difference of cubes more than likely. I look up and I'm like, well, 16 is not here, and 250 is not here. I personally like to choose the smaller of the 2 numbers, and I go up here and I go, can I take, and really doing something with the 1's probably not going to help us, but can I take anything times 8 and end up with 16? The answer is yes, it would be 2. So let's factor out a 2. 2 times 8 is 16, bring down the x cubed. 2 times 125 is 250. Now, am I done or can I keep going? Well, 8 and 125 are both up here. It's the second number in the list and the 5th number in this particular list you're looking at. So this breaks into 2 times 2 times 2, 5 times 5 times 5, x times x times x. Okay, forget about the 2 till the very end. I'm going to make what I describe as like that stamp. So the 2 and the x came before the plus sign. The 2 and the x came before. So 2 and x came before, and I cancel them out. And the 5 came behind. And now in front, 2 times 2 is 4, and there's 2 x's. X times x is x squared. And back, 5 times 5 is 25. So what symbol goes here? It's always opposite of the first. So if this is addition, this is subtraction. And what term goes here, you're going to multiply these 2. Forget about the signs. We already have it. 2 times 5 is 10, and attach the x. Now, if I stop right here, it would be wrong. Because what did I initially do? I factored out a 2. Now, this is completely factored. Can I have right now just a thumbs up or thumbs down on how you're feeling? Thumbs up, thumbs down. Okay, let's do another one. Let me see if I can actually just flip this up. No, that's not going to work. I'll just bring it back down here. Okay, so let's go with this one is going to be, just hold on. So 81 x to the fifth, 81x to the fifth, minus, whoops, 648x squared. This expression looks a little intimidating to factor. You're going to have a calculator in front of you. And so before we even worry about the variables, let's look at these numbers. So I can see 81, it's not up here, right? 81's not up here, and 648 is not up here. So I always like to start with the smaller of the two numbers. 81 is smaller, and so I'm going to go one by one. Can I take 8 times a number? And so if you're not great with just doing multiplication in your head, try this. My smallest number was 81, so I'm going to divide it by 8, and I'm like, oh, it doesn't work, because I don't have right here just an integer or a number with no decimal. So then I'm going to take 81, and I'm going to divide it by 27. I'm like, oh, okay, so if I take 27 times 3, I end up with 81. All right, let's try that. So if I factor out a 3 here, I'd get 27x to the fifth. Please take 648 and divide it by 3 for me. 648 and divide it by 3. And I end up with 216. And now I look back at the list and I go, is 27 and 216 there? 27, yes, and 216. But I can do more. So what's the most x's I can take out? Remember, this is really like x and x, and this is like x, 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 if I lined them up. This is 5 x's and 2 x's. So what's the most I can pull out of both of these? 2. Okay, so I'm going to rewrite that over here. And when I pull out 2 x's, this is what it looks like. 27 x to the third minus 216. I want to make sure I did that right. If I distribute, I get 81, and I would have 5 x's. If I distribute, I'd end up with negative 648, and I'd have 2 x's. Now, I'm only going to focus on this portion. At the very end is when I'll attach the 3x squared out front. Okay, so what do I do here? Well, okay, I know 27's up there, and I'm going to see which number is it in the list, and I know 216 is. 27 is the third number, 4, 5, 6. So this is the third number and the sixth number. Uh-oh. So here's what was a little alarming for me. When I knew this was the third number, and I knew this was the sixth number, give me 1 second, kiddos. Here's what was a little alarming for me. Do you see how 3 and 6, did everybody see how 3 and 6, that 3 is a multiple of 6? So I can take out even, so when I look at these numbers, I'm like, can I take even more out? I can. So I took 216, and I divided it by 27, and look, what else can I factor out? An 8. So I need to factor an 8 out of this still. So I have this part out front, and I'm going to grab another piece of paper so it's just a little bit neater for us to look at. I'm going to write down what I currently have. This is what I currently have. Okay? And I just realized that 216, when I divide it by 27, I get a nice whole number. And the number happens to be 8. So out of this portion, I'm going to forget about this to the very end. And I'm going to like, hey, I can factor out a 27 here. So 27 times 1 is 27, and there's the x cubed. And now I would take 216 and divide it by 27, and I'm left with 8. So here's really what I have right now. And the only part that I'm going to worry about is this part. And I'm going to do it quietly while students in front of me. I want you to not worry about this part. I want you to try to do this part at the same time I'm doing it. Just glance up and see if you're doing it right. I'm going to do it quietly to give you a chance to think without hearing me talk. So I have factored this sum or difference of cubes. I've done that. But what goes in front? I have to look at this part. So I know 27 times 3. 27 times 3 is 81. I'll just show that. 27, times 3 is 81, as you can see. 27 times 3 is 81. And I have an x squared. So here would be my final answer. That's what's factored out. Sometimes students ask, do I need to put a 1 in front of an x? It's not necessary, but I just did it there so everybody can understand what we're going over.